All right, everybody. My name is Mr. Oilar. Just quickly about me. I did a little bit of an introduction with the last trimester, but obviously that's not you guys. So, I am a practicum student at BYU, Idaho. So, learning to become a teacher. This is my first, my first practicum in a classroom. So this will be my first full lesson. I know I did a little bit of a half lesson with you guys earlier. Anyway, so I'm from Cody, Wyoming. It's pretty much just across Yellowstone Park from here. It's not too far. When the park's open, it's about a 3-hour drive. Grew up hunting, fishing, all sorts of stuff outside, but the wind gets so bad there, it's worse than here, trust me. Gets so bad there, I also spend a lot of time inside, so lots of movies, lots of board games, video games, that kind of stuff. Anyway.
Hello, this is Mr. Hendricks.
So, today,
No, he's out in the baseball field.
we're going to be doing the scientific revolution. So, just to kind of start, I'm going to ask you guys a couple of questions.
Be able to get back to you.
So, you guys just had an exam about kind of the Middle Ages. So, what did the world look like during the Middle Ages? What did Europe look like specifically?
A lot of war.
A lot of war. True.
Very religious.
Extremely religious.
Wasn't there like a lot of human waste everywhere?
Yeah, it's not super clean. There's not really indoor plumbing. People have kind of been living the same way during the Dark Ages that they had been for the previous 1,000 years. There's pretty much no development of any kind, really. So, we talked about they're very religious. What kind of role did religion play in everyday life?
Very big
I
part.
think you guys had to write an essay question on it. A very big part. Salvation was kind of the big thing about everybody's day. You know, you go to church 4 times a day. You're trying to get saved. The church kind of controls a lot of your life. So as far as that goes, what did most people do with their average day? The vast majority of people, what do they do?
Go to church, work.
So they go to church.
Go
What do they
back to
do
church.
for work?
Farming?
Heavily farming. Farming is the right answer. Most of the population spent time growing food. I believe it's roughly 30–40% of them. Everybody else kind of, craftsmen, that kind of stuff. So what role did science play in the life of the average person?
Virtually nothing.
Slim to nothing. Not very many people are educated. Science doesn't mean that very much to you. Basically, the most you do with science is you got to know when to plant your crops. So like basic agricultural science. You got to know when your cows are sick. You got to know how to help your pigs and stuff like that, chickens, whatnot. You're not really concerned about what's going on in the exterior of the universe, what things are made of, why it matters, that kind of stuff. Next question is, how would the lack of telescopes and other tools impact learning about our universe
Thank you.
before the scientific revolution? So, if you don't have tools to study science, are you going to study science?
No.
No. Do you have another thought? Yeah. No. You don't really study science. There's not really anything you can really do about it. So, this is kind of a big part of the scientific revolution, but why would the loss of authority in the Catholic Church and other religious institutions impact scientific learning? Yeah.
I would think that it was because then the church couldn't force you to do all of this stuff.
Absolutely.
Stuff.
So, where did the majority of scientific learning take place? And we talked about monasteries and how monasteries were kind of a staple in education. So the Catholic Church oversees most of education. So if the Catholic Church is teaching you that science is this way, and you're a Catholic monk, are you going to go against them on that?
No.
No, not really. So now we're going to get into the development of the sciences. So we kind of talked about the downfall of the Catholic Church, Protestantism. all this stuff is kind of taking place. So as the Renaissance is taking place, people are growing more curious about the way that the earth works. So they're starting to ask questions. They're starting to say, okay, why do the stars kind of move around the way that they do? Why does weather happen the way it does? That kind of stuff. So people kind of start to question traditional beliefs. People start to say, okay, this is what the Catholic Church says about what's going on. Is that really true? So they kind of start, the scientific knowledge starts to grow a little more secular. Does anybody know what secular means?
Split?
Kind of. Split is part of the answer for sure. It starts to split from religion. So it starts to become more of just a facet of everyday life rather than a religious part of your life. So these secular scholars begin to emerge as the church starts to lose its control of knowledge and learning. So these scholars, because of the Catholic Church, are starting to learn Latin and Greek and learn all of these different languages, because that's who was doing science before the Catholic Church came around, is the Romans and the Greeks. So they're starting to gain and start to learn more about all this knowledge that has kind of been suppressed by the Catholic Church. And they start to begin to develop their own theories. On top of this, we start to see universities and wealthy patrons begin to fund private experiments, because that's kind of the big thing in Europe as the Renaissance is taking place, as people are starting to have these questions. So having a scientist, if you're a rich person, having a scientist do experiments for you is one way that you kind of show that you're intellectual. So one of these early scientists is Nicholas Copernicus. He is a Polish, he was born in Poland. He's a Polish scientist. And he kind of starts to read some of these Greek theories about, and along with Catholic teachings about geocentrism. Now, breaking that word apart, does anybody know what the prefix geo means? It kind of means earth. Kind of a simple way to describe it. So they kind of view Earth as the center of our solar system. So he kind of starts to question that. And he says, I don't think the Earth is really moving quite the way it should be compared to all these stars. It doesn't really feel like the Earth is kind of the center. So he starts to kind of say, what if the sun is the center of the solar system? This idea, not really accepted by the Catholic Church. And so he starts to publish his work, and people are starting to get wind of this. And the Catholic Church says, like, hey, we got to shut this guy down. But before the Catholic Church can get to him, he dies of some disease. I can't quite remember what it was.
Are you ready? Sorry, I had to move it. You should be good with the rest of them.
Okay. So, again, even though his ideas were unsupported, he died before the church could take any action against him. And the idea of a heliocentric universe was very interesting to many scientists, leading to the spread of his ideas. So this is kind of a picture of both systems, the heliocentric model with the planets orbiting the sun, and then the geocentric model. This model is pretty interesting because it says that the planets kind of orbit in spheres around the Earth. So they can be anywhere on that sphere, and the sphere is perfect. Mathematically, it's perfect. There is no deviation in any way. It's a perfect sphere. So the Earth is kind of the center, and these planets kind of go out in rings, kind of like an onion. And again, heliocentric model is kind of what we have today. I'm sure you guys are kind of familiar with that. So the next guy to kind of pick up Copernicus' work is Johann Kepler. He uses his observations of astronomy, watching the stars, and used to kind of solidify the heliocentric theory. So he says, yeah, Copernicus is right. These stars aren't moving the way they should be if the Earth was the center of the universe. He also finds that these orbits aren't perfect circles. He finds that they're kind of elliptical or egg-shaped. That they kind of make little deviating paths in our solar system. And this, he kind of writes a book about it called The Laws of Planetary Motion. And he uses mathematical principles to support his theories. So this is kind of starting to come together for the rest of the Earth. Everybody else is starting to kind of get a hold of these ideas. And so this is kind of what an elliptical orbit would look like. As the planet gets kind of closer, it speeds up and then comes back out. And so that's kind of what we know today, is that these planets have elliptical orbits. None of them are perfectly circular. The next guy to do some big work is Galileo Galilei. Has anybody heard of this guy before? It's kind of a big name, Galileo. So he was born in Pisa, Italy in 1564. Studied at the University of Pisa. Initially studied medicine, but eventually he shifted to mathematics as he began to learn more. He thought mathematics were pretty interesting. And he starts to apply a little bit more mathematics to Copernicus's heliocentric theory. And he becomes a professor of mathematics at the University of Padua. Some cool facts about him is he found the telescope that people had been using for kind of seafaring and voyaging on the oceans. And he said, hey, if people can see stuff really far away using this concept, maybe I'll make my own telescope. And so he teaches himself how to make lenses, which is one of the hardest things to do in the field of glasswork. And so he develops a telescope. And using the telescope, he's able to discover some of the moons of Jupiter. I believe he discovers 4 out of them. And he uses his findings of watching the planets and other heavenly bodies and develops some laws of motion as well. He studied the planet Venus and confirmed heliocentrism, that based off of the way Venus orbits the sun, determines that the sun is the center of our solar system. He published a dialogue concerning the 2 chief world systems, kind of describing the difference between heliocentrism and geocentrism, and how the previous teachings of geocentrism are incorrect. The Catholic Church gets wind of all of his stuff. He brings a bunch of Catholic leaders and shows them his work through his telescope, and has some really convincing evidence. But the Catholic Church is kind of worried about what this kind of ideology can make people believe about the Bible, because they believe the Bible teaches that the earth is the center. And so, even though he has convincing evidence, they try him and find him a heresy. And he is forced to recant his work. So basically, what recant means is they tell him to take it back. And he says, his only other option is execution. They say you can be executed, or you can take back your work and say that it's not true. So he takes back his work. But he spends the rest of his life in house arrest, but he never truly gives up on his work. He continues to write more about his work, about a heliocentric universe, and is known as the father of modern observational astronomy. And his work laid a lot of the foundation for later modern physics and astronomy. He eventually dies in his home, but after he dies, they publish the rest of his work so that the Catholic Church can't get him to take it back again. I think we're on the next slide. Okay. So he recants his work. He's placed under house arrest from the ages of 67 to his death in 1642 at 77. All of his work is published after his death and contributes much to the field of astronomy. Next slide. So Isaac Newton. Anybody heard of Isaac Newton before? It's another big name. What do you guys know?
He the one who started to study gravity.
Yes. So he'll eventually study gravity, comes up with his 3D laws of motion. Yeah, so his early education, he's educated at Cambridge, and then later attends Trinity College in Cambridge, where he studied mathematics and natural philosophy. And he graduated from college at the age of 22. He's a smart guy. Natural philosophy is what they kind of called science back then. It was the natural philosophy of the way things work. Anyway, he returned to his childhood home and developed the laws of motion and gravity after his graduation. There was kind of a similar plague outbreak in London, and so they shut down the university, and he goes home and does a bunch of work in his laboratory. He uses the law of universal gravitation to explain planetary movement and physics on Earth. Soon after these discoveries, he publishes his book Principia Mathematica, which is just the principles of mathematics, which provides mathematical explanations for gravity, and these principles eventually are developed into calculus. He also did a lot of experiments with like natural light and the particles of light and stuff like that. So Isaac Newton created much of the tools that he needed to conduct his experiments and develop his theories while living on his family farm during this outbreak of the plague. So he sees old farming equipment and says, hey, I need to have stuff to be able to conduct experiments. And so he builds a lot of the tools that he needs. He's a super smart guy.
What was his book called?
Principia Mathematica. It's Latin for principles of mathematics. So these discoveries that Isaac Newton is making about physics and about mathematics help us to understand the world that we live in and the way that our universe works. And it paves the way for future scientists like Albert Einstein and his theories of relativity and lots of these other things, which you guys will have a lot of fun learning about later because that's pretty complex stuff. So here's it's a 3-4 minute video, just a biography. It does a little bit better job explaining the life of Isaac Newton. He's a pretty important guy.
Revolutionary English physicist, mathematician, and philosopher Sir Isaac Newton is perhaps the most famous scientist in history. Born to a farmer in 1642, Newton worked his way through school waiting tables and cleaning wealthier students' rooms. He went to university at Cambridge, where he would eventually earn a professorship. During the Great Plague in 1665, Cambridge shut down and Newton returned home. It was during this hiatus that he first conceived the method of infinitesimal calculus, began to theorize the laws of planetary motion, and started his work with light and color. Though his discoveries would change the world of science, he didn't care about the glory and fame that came with them.
He wasn't too concerned with publishing it, making it available to other people, getting glory if you don't say. It was an intellectual challenge that he wanted to deal with.
Every discovery that Newton made had two aspects. First, Newton made the discovery, and second, other people had to discover that he had made the discovery.
In 1671, Newton demonstrated his revolutionary reflecting telescope for the Royal Society, and soon after published his notes on color, describing his research on optics. After a visit from Royal Society member Edmund Halley, encouraging Newton to prove Robert Hooke's hypothesis on planetary motion, Newton wrote his Principia, which introduced his 3 laws of motion and first described the idea of gravity.
Newton's Principia is generally reckoned to be the single most important scientific book ever written, because for the first time it set forth a working, quantitative, exact, mathematical system based upon experiment and critical observation.
His work made him very popular and led Newton to being elected to Parliament. After several years in London, Newton suffered a nervous breakdown. Though he came out of it, his interest in physical science was replaced with philosophy and alchemy, particularly how they both related to a higher power.
Alchemy was concerned with manipulating what were seen to be four elemental properties in nature, the four elements, earth, air, fire, and water, and realizing that these things made all substances, that you could therefore not only make any other substance, such as gold, but you could also somehow learn the secrets by which God had put the world together.
Newton's later years were spent less in science and more as a public figure. Upon Robert Hooke's death in 1703, Newton became president of the Royal Society, though he didn't get along with many of its members, and made many enemies. Newton spent his final years a wealthy and famous man, whose discoveries made enormous impact on society.
In the century that came after Newton, in the 1800s, we find that the fascination with science, with order, and with reasoned knowledge really set the whole tenor of that culture. The one single figure from whom they drew most deeply was, in fact, Isaac Newton.
Hey, no, you're not.
So, so Isaac Newton, super smart guy, kind of sets up the world of science leading up into modern times. Like I said, his early years full of scientific experiment, full of achievement, full of that kind of stuff. After his nervous breakdown, he kind of leaves the world of science and becomes more of a public figure. But his work is extremely valuable. So science isn't the only thing that is making progress during the scientific revolution. There's also several other fields that are also developing, and one of those fields is medicine. So before the scientific revolution, much of what was known about human anatomy was derived from dissection of animals. Why would the principal knowledge of human anatomy coming from the dissection of animals maybe be an issue? Either one. Well, you can go first. We'll go to both, yeah.
We don't have the same structure as any other animal.
Yeah, our anatomy is different. Yeah, same thing. Anatomy is very different between different animals. So this knowledge kind of throws off the practice of medicine in several ways. That's why we get things like bloodletting and using leeches to cure diseases, and deciding that most diseases are religious in nature and that people have attracted demons and evil spirits and that kind of stuff. So not very much is known about the human anatomy that can be placed into the practice of medicine. So during the early 1500s, human dissection begins to further the field of medicine. So the story that I remember hearing is there was this man who found his wife cheating on him, and he murders her and their entire family. So it's a little bit of a dark story. Murders her and their entire family, and the city says, what are we going to do with this guy? So they hang him and donate his body to science. And that's one of the first human dissections performed during the scientific revolution. Is the scientists go through and they're able to accurately depict a lot of the human circulatory system, the respiratory system, digestive system. Lots of different parts of human anatomy start to be discovered. And because of this, another scientist who was working with this cadaver was William Harvey. He discovers that the heart is the center of the circulatory system, which is huge and groundbreaking. Before that, everybody had considered that the liver was the center of the circulatory system, which we know to this day is false. It does have a large part in cleaning the circulatory system, but it's not the center of it. Because of these discoveries, our perception of disease has changed, and although germ theory doesn't come around until later, there are some advancements in kind of the realm of sanitation, and people are using Galileo's concept of looking at planets really far away and turning them into like microscopes and starting to look at things that are really small. Another school that is making developments is chemistry. We have the scientist Robert Boyle, who formulates the relationship between pressure and volume of gases, that the more pressure you put on gases, the smaller space they take up. And this is really one of the foundations for modern chemistry, is starting to learn about this concept. Scientists begin to reject alchemy, which we heard a little bit about in the Isaac Newton video, in favor of experimental chemistry based on observation and measurement. And they start to observe and measure these different substances and determine that they are individual from each other, that Earth isn't just one element, that there's several elements within it. This leads to the discovery of several elements, chemists identifying substances like phosphorus, and in the improvement understand the possibilities between chemical reactions and what these mean, not only for like in terms of alchemy, not being able to create gold out of other items, but also being able to understand chemical reactions occurring within our bodies. So another scientist that is pretty important to the scientific revolution is Descartes. So Descartes emphasizes reason and doubt as the basis for knowledge, famously stating, "Come to go, ergo sum, I think therefore I am." So basically he's saying science is about having a question, it's about thinking. And science isn't just the way things are, but it's the questions we ask about the way things are. He develops Cartesian geometry, linking algebra and geometry. So any of you guys who are taking algebra and really hate it, this is one of the guys you can blame. It's Descartes. He starts to come up with the x and y axis. Anybody knows what that is yet? He promotes or proposed that the mind and body are separate entities, that this concept really influences philosophy and psychology, and that kind of just like our body functions on its own, so does our mind. Our mind kind of functions on its own as well. His books, such as the Discourse on Method and Meditations on First Philosophy, really shaped some Enlightenment thinking. The Discourse on Method kind of developing into what we'll go over at later as the scientific method. So Francis Bacon. Bacon really emphasized observation, just like Descartes, and experimentation over traditional pure reasoning and a basis for knowledge. Kind of the way experiments went before we use the scientific method is very classical, like Greek and Roman, where you kind of just sit and you talk about stuff. Like Socrates talking to his students, like, hey, this is kind of the way I think things work, and people would say, no, maybe you're wrong, and they didn't really do a lot of experimentation. It was a lot of discussion. So he starts to outline a systematic approach to inquiry. He starts to set up this practice of, in order to gain knowledge, first you have to do this, then you have to do this, then you have to do this. It's step by step. He wrote a book called the Novum Organum. In this work, he kind of criticized reliance on ancient authorities like Socrates and Plato, and proposed a new method of scientific investigation. Anybody here taking science classes know kind of what the scientific method is? Yeah.
The scientific method?
You don't have to give me all the steps, just give me kind of a general description of what it is.
You just have a question, and you have to test it, and then you form a hypothesis, and then
that scientific discoveries should be used to improve human life, that these scientific discoveries that people make can really start to help people progress, especially using technology and stuff. According to tradition, Bacon died of pneumonia after experimenting with preserving meats by freezing them, demonstrating his commitment to hands-on experiments. He kind of says, hey, I really believe in this, got to do experiments, ends up getting pneumonia and dying. So he develops the scientific method, which we've gone over. You ask a question, you identify the problem, you make a hypothesis about it, you do some research, then you test your experiment. And to conduct your test, to check your hypothesis, you write down the steps you take to do your test, you write down how you do your test, then you analyze the results of your test and draw conclusions, and using your recorded step-by-step method that you took, you share your findings. And this is really huge for the scientific community, because this is being practiced, but not quite completely, especially by Copernicus, writes down his findings, sends them out. Then Kepler records his findings, sends them out. And he says, you know what, Copernicus was right, but he wasn't completely right, and here's how I know he's not completely right. And then Isaac Newton comes along and says, these guys are right, but they're not completely right, and here's how I know they're not completely right. And they're building upon each other. And they're taking the knowledge from previous scientific generations and passing them on to the next one. So because of this scientific revolution and the development of the field of science, science has moved out of control of the Catholic Church into private, more secular functions. People begin valuing experience or evidence-based science over religious or traditional explanations. People are asking questions and they're putting lots of value in this work. New medical techniques are discovered, blood circulation, improved understanding of anatomy, and healthcare begins to transform into people doing these experiments to help further the field of medicine. The development of the scientific method, the heliocentric model becoming the way people view the world, and it really challenges the church's teachings and leads to a shift in how people see their place in the universe. People kind of start to say, well, if the Catholic Church is teaching us this and we know that it's wrong, then how much are they actually saying that is the truth? So people start to kind of question religion and start to take religion into their own hands, and this kind of helps in the Protestant Reformation. The ideas of the scientific revolution influence this Enlightenment, and they're starting a lot of new philosophical discussions. People start to use logic and reason. People start to wonder about individual rights, that if the divine right of kings is really something that needs to continue to be practiced. And people start to make shifts in government, which lead to later revolutions, which we'll get to later. And this is just kind of a video kind of talking about the importance of science in our world, in the concept of human history. It's that bottom one. Yep.
If you want today to say, why study this when we have these other problems? All I do is take you back to the cave. Let's say, all right, we're in a cave, and there's a mountain over here in the valley, and I tell the tribe leaders, I want to explore that mountain in that valley. No, we can't afford to send you out there now. We have to solve the cave problems first, before anyone leaves the cave. We laugh at that. That's an absurd claim to make in caveman days. I don't know if anyone did it, but that's a crazy thought, because there are solutions to your problems that might exist, and time has demonstrated likely exist by leaving the cave that you can then discover. So for me, exploration is not just space, all the frontiers of the unknown. Biology, chemistry, AI, you know those frontiers, and then you can cross-pollinate them and transform civilization. If you want today to say,
Awesome. Anybody want to take a crack at what Neil deGrasse Tyson is trying to say here? What do you got?
If we question why are we studying this one thing, they're basically not looking into what could the future look like?
Absolutely. So one of the big things of science and kind of why it's important to us, and it doesn't go for science, just for science for me, I would call it innovation. Anybody know what innovation means? Yeah.
You take something and you make it better.
You improve something. And so innovation is kind of what's really allowed us in the last few hundred years to really advance, to really make the human race into what it is today. So I guess what I would want to say to you guys as students is learn as much as you can and find something that you're passionate about so you can contribute to whatever field it is you decide to go into. That's one of the big things that we have as an advantage as human beings over every other species on the planet, is our ability to contribute to each other to help move humanity forward. All right, so kind of moving on, conclusions from the scientific revolution. How are these scientists, kind of using the video that we just watched, how are they trying to solve problems by developing an understanding of our universe? What problems might they be trying to solve?
Religion.
Religion, that's a big one. It's trying to reconcile religion with facts. Anybody else? Yeah.
Medicine.
Medicine is a huge one. It's trying to say, hey, why are people getting sick? This is one of the things that we need to really improve, especially when it comes to how our bodies work. This is one of the big questions that kind of helps further humanity. So we kind of talked about this a little bit earlier, but how does the recording and transfer of useful data improve our situations? Yeah.
Because when you record and transfer your data from like an experiment, someone else can look at that, do the same test, do the same steps, get a different outcome, and then also publish those.
Absolutely. So it develops a dialogue. And so I'm still taking courses over at BYU Idaho, and this is one of the big things that I'm learning about right now, is kind of this dialogue of intellect. What we're doing right now is I have a class on Roman history, and one of the big things we're doing right now is reading historians or ancient political scientists kind of discuss the topic, and they'll say to each other, you're wrong because of this and this and this. But the work you do is valuable, and we really value that you've asked this question because it has us thinking about it. And so then another historian will come in and they'll say, okay, well this guy makes some good points, but he's wrong here and here and here, and the development is continuing. And this happens in science, in history, in education, in mathematics, not so much anymore in mathematics because we've kind of got that one pretty down, but this development and transfer of useful data and being able to accept criticism and be able to improve our understanding as humans is really a big concept. So for you guys, why is it important in your high school, adolescent lives to continue the development of knowledge as a whole, as a human race?
Because there might be new problems we have to solve in the future.
Absolutely, and I think that's 100% true. There's probably problems out there right now that we don't even know about. Nobody's asked that question, so we haven't made it there yet. So it's important to develop our knowledge so we'll be able to ask the important questions, we'll be able to find the important answers. So that is kind of what I would leave you guys with today. And so we're going to go ahead and move on to kind of our exit ticket and maybe an activity if we have time. So what I want you guys to do is I want you to write down I have the papers over here, so I'll hand them out in just a second. But one historical person and one thing that they contributed. And as you're writing this down, it doesn't need to be super long. You can go first or last name of anybody. Two in this row. And I'll collect these at the end of class. Just one thing, one per the name of the person, and one thing they contributed. You got the instructions right up here. So you fill in this entire thing. So I need 5 individual names and 5 contributions. You don't fill it out, not a big deal. This isn't for a grade. How much time do we have left?
13 minutes.
13 minutes. Don't worry about the backside, we'll get to that later. So fill out the side that's up there on the board. Don't worry about the backside. That's if we have time, we'll get to that. We're going to give you guys about 5 to 7 minutes to work on that. Not looking for any specific answers here. There's, I think, in this presentation I gave you guys probably 8 names and at least 20 different contributions from each of them. Don't need anything super specific. Even if you don't remember names, you can write down just the contributions or kind of some of the developments. you guys are finished, just go ahead and raise your hand. Go see how many you guys are doing. Alright, we'll give you guys a couple more minutes.
If he lets me. Friday's Thursday. That means lunch is like next hour.
Cheap charges.
It smells like the actual baking food. Oh my gosh, how do you say that? Good job.
Okay, we got 1 minute left. So, who wants to share their first scientist? Who do you guys have for the first one? What do you got?
Isaac Newton.
Boom. Great. Anybody else? What was one thing Isaac Newton contributed? What's that, gravity? Perfect. Number 2. What do you got? Galileo. What do you contribute? Yes, astronomy. Number 3. What do you got?
Johannes
Kepler. Awesome. What did he contribute?
Further heliocentric and elliptical sensors.
Awesome. Number 4. What do you got?
Nicholas Copernicus
Copernicus? You can go next. What do you contribute?
contributed the first like a theory of heliocentric model.
Perfect. First heliocentric model. What do you got?
I got Robert Boyle.
Boyle.
Yeah.
What did Boyle do?
And the relationship between pressure and volume of gas.
Pressure and volume of gas. All right. Anybody who didn't have their stuff filled out, time's up. So we're gonna go to the next thing. So on the back, what I'm gonna have you guys do is you're gonna write one word and then pass your paper to the next person. We're kind of gonna do a snake thing. So we'll come forward here in the back. Yeah.
Like any word?
So, what I want you to write is I want you to write one thing you've learned so far in this class that has advanced the human race in a historical fashion. So, for example, you could say the Crusades, or you could say Protestantism, or you could say the Renaissance, or you could say the plow, because the plow's been kind of reevaluated.
What if you have like terrible stuff?
Alright, here you go, Alex.
Doesn't matter.
Hold that.
So you are gonna go that way with it.
There you go, man. I put the plow. Is that okay?
And you guys are gonna jump down. I'll pass it across the aisle over here.
My paper's gonna get. I didn't write my name on my paper.
You're cooked.
You got work yet?
Oh yeah, I did. No,
I go that way?
Yes, you're going back.
What about you?
You're going forward. You're going
Wait a
forward.
minute. Do I go forward then?
So this one comes over here. This is coming back. Don't
Oh, right. I go over there.
You get over there, I don't know.
You finish your work.
Let's do it so it makes sense like the Renaissance thing.
Perfect. It doesn't matter whose paper you end up with. I'll collect all these at the end of class, so I'll get them all eventually. You're gonna pass. Yours back here.
You take.
E-L-O-W.
And then you're coming across over here.
Yeah. I'm gonna just read it.
Back. The back row, you're going across and forward up to here. You guys write one word and pass it to the next person.
You just continue writing.
Yep, just keep putting words down. Keep them coming.
I'm gonna
Keep writing.
Someone create a ball.
Just seriously, just write any word.
It's fine.
Yo, I'll pay you.
You're going
Oh, you wrote the plow. Who wrote the plow?
You don't put the flowers there. You not write the same word every single time. Try to find a different word when you have a
I don't know a different word.
You're great. Don't worry about it.
No.
I don't know a different word.
Alright. Got a bunch of papers coming through here.
Oh, that makes
Oh my
no
gosh.
sense.
I don't know how to spell that.
Hey, wait, there's a lot.
It's got 3 minutes left. See how many terms you can get out.
Yeah, I do.
You can write people's names as well. People's names.
That is not how you spell that, but tism. Protism.
Why? Why can't I just be in the middle? There's so many now. I can't write the same thing over and over.
Sorry, I think you guys will back up here.
God.
Start to move forward with it. And then you can pass it.
I'm just gonna do this.
Pass it here.
Are we supposed to write like wait, paragraph that makes sense?
No.
You're just
I'm just looking for terms. I'm just looking for terms. What do you guys know?
terms. I'm actually like writing a story. Yeah, me too.
If you're writing a story, that's great.
It was like influenced by.
So pass yours to him, and then he can pass it back. You start passing forward.
Forward.
Tism
brains. He wrote his Bible.
Try to stick to actual terms. I'm pretty sure Tism Brains is on there.
Oh man. I don't know
Stack?
what
Perfect.
this one I will write this.
God.
Another stack.
Right when I think I'm done, I have like 6
You
more.
guys got 1 minute left. Let's see how many you can get. Everyone.
Screw that!
Adios. As you walk out.
Oh, I don't want to the 4th hour.
I need your papers. Bring me your papers if you got a stack of them. No, a stack.
Oh, no, it's not mine.